Hello everyone, welcome to our sessions. In this series of videos, we are going to cover 9 chapters of Pure Mathematics 1. Chapter 4 is Graphs and Transformations. In this video, we are going to cover cubic graphs and reciprocal graph. We will explain each topic step by step. We'll do some book exercise questions. We'll show you how to solve some past paper questions and we'll give you some exam success tips. So let's start our journey. Topic 4.1 is cubic graphs. Cubic function has the general form ax cubed plus bx squared plus cx plus d, where a, b, c, d are real numbers and a is non-zero. Because if a is equal to 0, that means this cubic term will be not there and it become quadratic function. So that is very important condition. A has to be non-zero, real number. The graph of cubic function you can draw depending on how many solutions that function has. For example, if your A is positive and you have only one intersection point or only one value of x which is 0, then this type of the graph is there. If you have a two value of x from your function, so one is here and one is here, then this type of the graph is there. And the second thing, the positive A graph start from the positive side of a x and ending it to the negative side of the x. Very important things. Now, how the graph look like when you have a is negative? So in that case, your graph start with negative x side and ending at the positive x side. Here they have x is equal to only one value which is 0, and here x have a 3 value, as you can see here. One is here, one is here, and one is here. So depending on how many values of function x you have, you can draw the graph. Let's move to exercise 4a. First question, sketch the following curves. Indicate clearly the point of intersection with the axis. So we have to find intersection point with x-axis and with the y-axis. Okay. So first, for this function, we have to take x is equal to 0. So as you can see in this function, if I put 0 into 2 0 minus 1, 0 plus 3, anything multiplied by 0 will give you 0. So the first coordinate we are getting, which is x0, y0. This is the y-intersection. If you put y is equal to 0, then you will get 3 value of x is equal to 0, 2x minus 1 equal to 0, so x is equal to half, and x plus 3 equal to 0, so x is equal to minus 3. So one coordinate you are getting for x is a 0, 0, we already got it here. Another is half and 0, and the third one is minus 3 and 0. So this way we will get all the coordinates or intersection point with y-axis and x-axis. Now how to sketch it? So we know our A is positive, or you can say this is the positive cubic graph. So it is start from the positive side. Now we have a half value positive which is here, and we have a minus 3 value here. So our graph will start like this, passing through 0 and passing through minus 3. Should be like this. Okay, and the y is also 0 0, so this is the 0 point that we can write here. This is our x-axis and this is our y-axis. So our graph is look like this. Now very important thing you have to keep in mind, whenever we are drawing the cubic graph, always we have to mention the range in the sense, if x tends to infinity, means we are talking about here. So when it's going infinity up, then y is also tends to infinity, because y is also the positive side it's going it. And for this side, if x tends to negative infinity, then y also going, because this is also negative y, so to negative infinity. This is very important things you have to mention whenever you will sketch cubic graph. Let's move to another question. Question 2. Sketch the curve with the following equations. So we have this equation y is equal to 1 minus x squared into 3 plus x. First substitute x is equal to 0. When you substitute here 0 and here 0, you can get y value 3. So the first intersection point for y-axis we are getting is 0, 3. When you substitute y is equal to 0, because of two bracket we have a two solution. So 1 minus x squared is equal to 0. 1 minus x is equal to 0. So x is equal to 1. So our coordinate is 1, 0. For another solution, 3 plus x is equal to 0. X is equal to minus 3. So another intersection point is minus 3, 0. Here we have only two intersection point for x. Okay, now let's sketch it. This is my x-axis, this is my y-axis. First put the point for the y. I need a 0, 3. So suppose this is a 3 is there. You know, these graphs are not up to scale. We are just drawing it or we are just sketching it. This is 1, 0 and this is minus 3, right? Okay. So, and it's a positive x graph. So it starts from this is the way you can sketch it. So this is your graph. This is the 0, 3 point. This is 1, 0 point. And this is minus 3, 0 point. So this is the way you can sketch it. Now again, if you remember, we have to write a range for this. So this is positive. So x tends to infinity. Y also tends to infinity. Tends means is going towards the positive side. X tends to minus negative infinity, y also tends to minus negative infinity. So this is how you can draw the cubic graph. Okay, one more question, question 3. Factorize the following equations and sketch the graph. So here we cannot have a direct intersection point. So first we have to factorize the function. So for that, first y is equal to, I can say x squared is a common here and I can write x minus 9. So this is how I can factorize it. Now you can find the intersection point. X is equal to 0, y also equal to 0. And when y is equal to 0, x squared is equal to 0 means x is equal to 0. So intersection point is 0, 0. X minus 9 equal to 0, x is equal to 9. So the coordinate we are getting which is 9, 0. Okay. Now we know how to sketch graph. Draw x-axis and y-axis. Put the point, this is the 0, 0 point. This is a 9, 0 point. Or you can say the 9 axis is there. So how we can draw this graph? So it's pass from the 9, pass from the 0, going like this. Now you have an idea how to draw the cubic graph. Now in this question, the graph is given, intersection points are given, as you can see in a graph. You have to find the function by finding the value of b, c and d. So how we can do this one? So first find the value of b, c, d and write down the coordinates of the point where the curve crosses the y-axis. So first we are finding this value. So I can see my first intersection point x is minus 3. So what my factor should be? So x plus 3 equal to 0. That's one of my bracket I am getting it. When x is equal to minus 2, x plus 2 equal to 0. And x is equal to 1. So x minus 1 equal to 0. So this is three factors we can assume from the intersection point. Now we have to put these two factors together, x plus 3, x plus 2, x minus 1, and expand it. If you are not good in expansion, you can go to my algebraic expression part 2 video that can help you. First, I will simplify this two bracket. So, x squared plus 2x plus 3x plus 6 into x minus 1. So, x squared plus 5x plus 6 into x minus 1. So, x into x squared plus 5x plus 6 minus 1 x squared plus 5x plus 6. So x cubed plus 5x squared plus 6x minus x squared minus 5x minus 6. X cubed 5x square minus x square will give me plus 4x squared, plus 6x minus 5x will give you plus x minus 6. Now equate this our equation with the given equation. So you can say a is equal to 1, actually we don't have to find a, b is equal to 4, c is equal to 1, and d is equal to minus 6. So this is the answer for part A. Now part B, write down the coordinates of the point where the curve crosses the y-axis. Now for this case, in this given function, we have to substitute x is equal to 0. So y is equal to 0 cubed plus 4 into 0 squared plus 0 minus 6. We will get y is equal to minus 6. So the coordinate when the point intersect the y-axis, which is here, which is 0 and minus 6. So this is our answer for the part B. Okay. Question number 7 is telling we have this function f of x is equal to, and I have to simplify in the form of x into ax squared plus bx plus c, where a, b, c are real constant. Okay, I'm rewriting first this function. So f of x is equal to x minus 10, x squared minus 2x plus 12x. Now, as you can see, I need x common, and I can see in this bracket x common is there. So I can rewrite like that, x into x minus 10, x minus 2 plus 12x. So from this bracket I take out x common. Now there is two terms are there, and I can see x is common in this both. So from the whole I can take x common, and I can write x minus 10, x minus 2 plus 12, right? Now for further simplification, we have to expand this two bracket. That will give us x squared minus 10x minus 2x plus 20 plus 12. Further simplification, because these are like terms and this also like terms. So x squared minus 12x plus 20 plus 12 will give us 32, right? So this is our required form. You can say it's a ax squared plus bx plus c form is there, right? Now part B. Part B is telling hence factorize f of x completely. Now this is my f of x that we found it, and whenever they are telling hence means we have to use the part A answer. Now we know how to factorize quadratic equation. So you have to use two numbers that multiply 32 add up to minus 12. So which is x minus 8 and x minus 4. So I'm getting these three factor of this given function. Now we have to sketch the graph of this function. Now, to sketch, we have to find the intersection point. So I know x is equal to 0 because x is here, so y is also equal to 0 because whole thing multiplied by 0 is 0. If y is equal to 0, x is equal to 0, x minus 8 equal to 0, so x is equal to 8. So one coordinate is 0, 0, other coordinate is at 8, 0, and x minus 4 equal to 0, x is equal to 4. So this is 4, 0. So I am getting this coordinate. Now let's sketch the cubic graph, x-axis, y-axis. First I am substituting, not substituting, we are putting the point 8, 0. This is 4, 0, and this is the 0, 0. So we can draw like this, right? And if you remember guys, always we have to write the range. So x tends to infinity, y tends to infinity. X tends to minus infinity, y tends to minus infinity. So this is the answer for part A, B, C. Next topic is reciprocal graph. You can sketch the graph of reciprocal functions such as y is equal to 1 over x, y is equal to 1 over x squared, or in negative y is equal to minus 2 over x, considering their asymptote. Now what is asymptote? So asymptote is a line which the graph approaches but never reaches. So for example, here the x-axis is the asymptote. The graph is going but is never touch or intersect the x-axis. So here we can say x-axis and y-axis are the asymptote. Okay. Now when y is equal to k over x, k may be any real number, positive real number, then your graph is always in the first and third quadrant. So you know that is 1, 2, 3 and 4. 4 quadrants are there. In that the positive reciprocal graph is always in a first and third quadrant. When your k is negative, less than 0, then your graph is in a second and the fourth quadrant. Why? Because in this quadrant x and y, x is negative, y is positive. Here x is positive, y is negative. So that will give you the negative value. When y is equal to 2 over x squared graph is there. Now we know that in that case, any value of x, when you do the square, always give the positive value. So our graph is in first and the second quadrant because here all the values we are getting of y which is positive. And if your k is less than 0, so minus 5 over x squared, then you will get your graph in third and fourth quadrant because you are always getting your y value which is negative. So with the practice you can understand, but this is the way we have to remember the reciprocal graph. Now let's sketch graph y is equal to minus 3 over x and y is equal to minus 8 over x. First, sketch x-axis and y-axis. Now the first thing we should know, this is a negative reciprocal graph, means it will come in a second and the fourth quadrant. That's the first thing we should do. Now if your x is less than 0, that means minus 8 over x is greater than minus 3 over x if your x is less than 0. But if your x is greater than 0, then minus 8 over x is less than minus 3 over x. So in that case, how to sketch it? So first graph, this graph is y is equal to minus 3 over x. Same here on this side. y is equal to minus 3 over x, and second graph here, this is graph y is equal to minus 8 over x. This is also y is equal to minus 8 over x. So this is the way we can sketch positive and negative reciprocal. Question 2, use a separate diagram to sketch each pair of graph. So first is y is equal to 3 over x squared and y is equal to minus 3 over x squared. So here, first obviously draw the x and y axis, right? Now we know here 3 over x squared. That means my k is positive and my x is also positive because its x squared is there. So that graph in a first and the second quadrant. So it look like this. Right? And for this graph, y is equal to minus 3x squared. So I can see my k is less than 0. My x is greater than 0 because square it, but my k is less than 0. So that will give you the negative value. It should be in a 4 and a 3 quadrant. So it look like this. So this is the graph for y is equal to minus 3 over x squared, and this is the graph for y is equal to 3 over x squared. So this is the square reciprocal graph. Now let's move to past paper questions. On diagram, sketch the graph of, we have two functions, y is equal to x into 3 minus x and y is equal to x into x minus 2, 5 minus x. So this one is a quadratic graph, this one is a cubic graph, right? So first find the intersection point so we can sketch the graph accordingly. Now for this, x is equal to 0, y is also 0 because it's multiplied by x. And when y is equal to 0, x is equal to 0 and x is equal to 3. So this coordinate is 0, 0 and this coordinate is 3, 0. But here I can see 3 minus x is there. That means when we sketch the graph, it's the downside graph is there. Okay, now look for this intersection point. Okay, first I will draw the quadratic graph. Okay, so this is my x-axis and this is my y-axis. Okay, so for quadratic I need one point which is 0 and another point I need which is 3. And because the one of x is negative, my graph is look like this, right? Okay, this is we are done with the first. Now look for the second one. Here y is equal to 0, then x is equal to 0, x is equal to 2 and x is equal to 5. So we are getting 0, 0, we are getting 2, 0 and 5, 0 value. And when x is equal to 0, y equal to 0, so that is 0, 0 point again we are getting. And here also, you can see one x is negative, means the negative cubic graph is there. So I need a point 2 here and I need a point 5 here. Okay. So because of it's a negative cubic graph, start from the negative side. So it's passing from here, going on 2, passing from 2 like this. So this is my cubic function graph. So this is the how graph look like. The curve should be a little bit proper. So this type of the questions are there in your. Okay. Now part B of that question. The x coordinate of the points of intersection of this and this function are given by the solution to this equation. So we have to simplify these two functions as this way. And we know to find the intersection point, we have to equate these two functions. So I can write x into 3 minus x is equal to x into x minus 2, 5 minus x. Now here, I can cancel x this side, but I will not do it because I need x here. So what I will do, I will move this whole thing onto the left hand side. So x into 3 minus x minus x into x minus 2, 5 minus x is equal to 0. Because I need equal to 0, I need x. Now from these two terms, I am taking x common. So 3 minus x minus x minus 2, I have to put a big bracket, and 5 minus x equal to 0. First I have to expand these two bracket. So 3 minus x minus, when you multiply, which give us minus x squared plus 5x plus 2x minus this is plus 2x and minus 10 is equal to 0. So x into 3 minus x minus x squared plus 7x minus 10 equal to 0. Now when we open the bracket, the minus is there, so we have to change the sign. So 3 minus x plus x squared minus 7x plus 10 equal to 0. So now I have to simplify this part. So x squared minus 8x and 3 plus 10 will give us 13 equal to 0. So this is our required form. So as you can see, x squared minus 8x plus 13 is equal to 0, right? Now move to part C. The point P lies on the both curves. Given that P lies on the first quadrant, find using algebra showing you are working the exact coordinate of P. Now for that I have to find the coordinate. So I have to factorize our given function. So our functions, the last what we get is x squared minus 8x plus 13 is equal to 0. Now x is equal to 0, it's not in the first quadrant, so we have to factorize this function. Now I can't use the splitting middle term or any other thing, so I am using quadratic formula. So a is equal to 1, b is equal to minus 8 and c is equal to 13. Put it into calculator and you can find x is equal to minus 8 plus or minus 8 squared minus 4ac over 2 into 1. So we are getting two value of x, which is 4 plus or minus root 3. So 4 plus root 3 will give us 5.7 and 4 minus root 3 will give you 2.26, right? Now 5.7 is in the fourth quadrant, but we are telling that is in the first quadrant. So we will consider this value, which is 4 minus root 3. Now we are finding coordinate. So this is just value of x we are getting it. So we have to find value of y by substituting any of the equation. So we have a first equation, y is equal to x into 3 minus x. So in this I am substituting value of x, which is 4 minus root 3. So y 4 minus root 3, y equal to, and 3 minus 4 minus root 3. I have to keep in a bracket. Okay. So when I simplify 4 minus root 3, and when I open the bracket, 3 minus 4 plus root 3. So 4 minus root 3 and 3 minus 4 will give me minus 1 plus root 3. Again we have to expand the bracket. So that will give us 4 into minus 1 plus root 3 and minus root 3 into minus 1 plus root 3. So this is easy way because negative sign is also there and root is also there. So minus 4 plus 4 root 3 plus root 3 minus root 3 times root 3 will give us 3. So minus 4 minus 3 will give you minus 7 and 4 root 3 and root 3 will give you plus 5 root 3. Right? So we got the coordinate which is 4 minus root 3 and minus 7 plus 5 root 3. So this is our required answer. Part C, hence or otherwise, find the coordinate of P, this is the point here, and the gradient of the curve at point P. Now, to find the coordinate of P which is on the y-axis, in this equation we have to substitute x is equal to 0. So when you substitute, then f of x, or you can say y is equal to 45 because these all terms has become 0. So the coordinate what we are getting is 0 and 45. So this is the coordinate of P. I can write here 0 and 45, right? Now the gradient of the curve at P. Now to find the gradient, if you learn in IGCSE, we have to use the differentiation. If you don't know, we are going to cover in topic chapter 8 in this pure one. So how to do the differentiation? So f of x is equal to, I am writing the function equation again. Okay. So to do differentiation, we have to multiply 3 with this number, that will give you 6, and then we have to put 1 powerless which is squared. 7 times 2 14, 1 powerless is x, minus 12. Here there is a 1 power and 1 minus 1 is 0, so that's it. And in this, because we are finding the gradient at this point, in this again I have to substitute my value of x which is 0. So f dash x, that because when we are doing derivation we have to do f dash x is equal to minus 12. So this is the gradient at point P. So we can write gradient at point P is equal to minus 12. So this is answer of part 1 and this is the answer of part 2. Important takeaway for this topic. When we have to draw the cubic graph or when we are drawing a cubic graph, it intersects x-axis maximum 3 points. It can be less than 3 points, maybe it's a 0 or maybe it's a 1 or a 2, but maximum 3 points are there. So when you solve the equation, you will get 3 values of x. Second, to find the intersection point on x-axis, factorize the given function and find the value of x. So you have to simplify, you have to factorize and find the value of x. If curve crosses x-axis, then you have to take y is equal to 0, and if the curve crosses y-axis, we have to take x is equal to 0. So that will give you the coordinate or point of intersection. Check what happens to y for a larger positive and negative value of x. So did you see in in the cubic graph how we are used to write it, like if x tends to infinity, y also tends to infinity. This is the range that we have to show, and x tends to minus infinity, y tends to minus infinity as well. But this is depend on what type of graph is there. For example, you have this graph, then we can write like this. Suppose you have this graph. right? This is the cubic graph. So for that the range is little bit different. X tends to negative infinity, then y tends to positive infinity. And when x tends to positive infinity, then y tends to negative infinity, which is opposite. So depending on what type of the graph is there, you have to do this one. Thank you for watching this video. If you find this video helpful, please give it thumbs up. Do subscribe for more math content and let me know in the comments if you have any questions or topics that you would like to see next.